Hello, ladies and gentlemen. The topic of this lecture is inverse of a function. If you can, please excuse me. I've been really sick with a pretty high fever, so I'm sorry that this is getting out so late. But inverse of a function. Here are our objectives: to be able to recognize and produce the inverse given a set of points, to be able to recognize and produce the inverse of a function from a graph, and to be able to produce the inverse of a function from an equation. So first, the definition of a function, or the inverse. If f of x equals y and g of y equals x, then g of y is the inverse of f of x. So in other words, if I input an x into f of x and I get y, then I put that same y into another function g of x and get the original x, then g of x is the inverse of, oops, hold on, of f of x. The inverse of f of x is denoted as f inverse of x. Here's another way to look at it right here. So look at this example. If a maps to 3, well, if I come down here to the inverse, 3 maps to a. You get it right back. B to 1, inverse is 1 to b, and then c to 2, and then, as we would assume, 2 to c. So which of the following groups have the correct inverse? Well, my original x is negative 2. I get 5. So if I put 5 in, I get negative 2 back. 0 to 6. So if I put 6 into the inverse, I get 0 out. That checks out. I put a 3 in, I get a negative 2 out for my original function. So I put a negative 2 in and get a 3 out for my inverse function. I put a 4 in, get a 1 out. Put a 1 in, get a 4 out. That checks out. Yes, inverse. Oops. Check. Alright, this one. I put a 5 in, get a 5 out. Put a 5 in, get a 5 out. Put a 2 in, get a negative 1 out. Put a negative 1 in, get a 1 out. Alright, so we can see here I put a negative 1 in. I should get a what back out? I should get a 2, but I get this 1. So that means that this is not a correct inverse. And then we can look at it another way right here as a set of points. If I put negative 2 in, I get 1 out. So I put 1 in, I get negative 2 out. That checks. Negative 1 to the 2, 2, negative 1, that checks. If I put a 0 in, I get a 3 out. I put a 3 in, 0 out of the inverse, and 1, 4, 4, 1. This checks out as well. So let's look at the inverse from a graph, and I'm going to have to change my color here. We'll go with a blue. All right, so let's look at our first point here. Our coordinate is 1 to negative 3, 1, 2, 3, 4, 5. So negative 3, 5. So where am I going to plot the inverse of that point? Well, it's just them flipped around, so I need to go to 5, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. So that would be my first point, and that is at 5, negative 3. For this one, I'm at 0, 1, 2, 3, 4. So this point is 0, 4. So to plot that inverse, I go to 4, 0. 1, 2, 3, 4. My last point is at 1, 0, so I need to plot the inverse at 0, 1. 1, 0, 0, 1. Alright, now, do we notice anything about this graph that's quite particular? Well, if we look, we got this kind of imaginary line that comes right through here. And that should come more like that. And it reflects, this point reflects directly across it to that point. This point reflects there, and then our far outside points reflect exactly across it. So that's how you can also look at the inverse on a graph, is that it reflects across this And this line is what's the equation for this line? Yeah, y equals x. Then that's our imaginary line that everything reflects across. Let's look at some more examples of the symmetry here and the reflections of different graphs. So let's first look at our absolute value graph, the V, right? Now, if we go ahead and put the inverse on there, we can see now we have our original function, g of x, which is the blue line, and then our red line reflects exactly the same way along that axis I was talking about. If I go to move this, oh, you could still see the reflection, how when my original function moves up 2 units, my inverse moves to the right 2 units. And opposite the other way, see? We could take a look at a different function, let's say maybe a quadratic function. We could see the same thing. Now, really, the inverse of a quadratic function is just a square root function, which would just be this top part. But we will get more into that later. And then you can see as you shift everything around, it still is reflecting across that. This point is still reflecting that point, and so on and so forth. Inverses on a graph. Now, inverse of a function from an equation. So when finding the inverse of a function from an equation, we have two steps. Flip the x and the y, and then solve for y. So by flip the x and the y, I mean just basically switch spots with them. So I have x equals 2y minus 3. Now my next step, solve for y. So now I got to try to get y by itself again. So it's going to be kind of the opposite of everything that we should get, right? So plus 3, I have x plus 3 equals 2y. And then I divide everything by 2. So I get y equals x plus 3 all divided by 2. Alright, so let's test this out mathematically. Now, let's say I choose x equals 2 to try this. So I go 2 times 2 minus 3. 2 times 2 is 4 minus 3 equals 1. So I'm going to take that 1 and I'm going to plug it into my inverse down here. So I get 1 plus 3 divided by 2. 1 plus 3 is 4 divided by 2 equals 2. 2 matches the same input we had up here, 2. So this checks out, this works. Let's check out one more example of this. So something a little bit more tricky here. So y equals the square root of 2x plus 1 minus 2. Well, our first step, right? Switch our x and y. So we have x equals square root of 2y plus 1 minus 2. Now, anytime we're solving an equation and we have what I call the operator, we need to try to get the operator separate first and then get rid of it. So I have a plus 2 to get rid of that, plus 2. That gives me x plus 2 equals the square root of 2y plus 1. Now to get rid of the square root, we square both sides. So that gives me x squared plus 4x plus 4 equals 2y plus 1. Subtract 1 from both sides. And I have x squared plus 4x plus 3 equals 2y. And my last step is to divide everything by 2. So I will leave it in the form y equals x squared plus 4x plus 3, all divided by 2. Alright, so let's check this to make sure that this really does work out. So I have the square root, let's let x equal 4 this time. So I have square root of 2 times 4 plus 1 minus 2. Let's see, 4 times 2 is 8, plus 1 is 9. Square root of 9 is 3, minus 2 equals 1. So if I plug that 1 in here, I get 1 squared plus 4 times 1 plus 3, all divided by 2. So that gives me 1 plus 4 plus 3 divided by 2. 4 and 3 are 7, plus 1 are 8. 8 divided by 2 equals 4. 4 here matches the 4 here. And so, check, we are done. Alright, thank you for sticking through me in my stuffiness and my sickness. Make sure to go answer the questions after you watch these videos. And I will see you in class. Have a good day.